Hello class. Today we're going to look at how to use the built-in financial calculation functions in the Texas Instruments BA2 Plus calculator. Now, normally I'm a mathy guy. I'm a huge fan of using equations. I wouldn't normally deter you from that, and you certainly can use equations for test 2 if you want. We will have a little bit of equation work to do potentially even when we're using the built-in functions of this calculator. And I think it was really valuable last week using equations to give you a sense of how compound interest works and a deeper understanding of what's going on inside the calculator. Again, anything that can help you, because I know that when you're using built-in functions and if you do one thing wrong, maybe you might get a number that doesn't make sense. But if you don't have some background understanding of what's going on, you might not realize the number doesn't make sense. Admittedly, for a lot of questions we'll be doing, you might not be able to tell for sure if a number is correct or not just by looking at it. But hopefully, I'll give you some hints here and there. At least you should have an idea of, is the number at least in the correct direction? Like, generally our investments that we start with a principal of $1,000, they should grow over time. We're going to assume for most of our questions we'll have positive interest rates, things like that. I really recommend at this point moving to using the built-in functions. That's going to be this light gray row of keys, the third row down on the calculator from the top. And I'm going to teach you now how to do it. The reason is, the quicker and more skilled you get at using these, well, for one, if you're ever doing this for an actual job after you're finished at Conestoga, you're going to use computer software, or you're going to just search the internet for a mortgage interest calculator, or you'll use Excel, or you'll use this calculator. So you might as well get familiar with other systems, other ways to do this. This course is a math course, but it's more about what we apply all this math to. In fact, today we're going to, after this, we're going to go through about 8 different questions applying all this sort of math to all different types of examples, financial calculations, different types of investments and such. And it's more important to understand how all those function than to be super skilled at solving the same formula over and over, which hopefully, if you've done enough practice last week, you should be pretty good at it anyways. But the other fact is, in this course, you absolutely need to start using this calculator, the built-in functions for test 3 and test 4. Because while I will show you the equations, there are questions that you couldn't solve on the test for 2 reasons. One is the equation when we get into mortgages. Now we're talking about a set of payments over 20 or 30 years. The equation is a little more complex, and it actually cannot be perfectly rearranged to algebraically solve for all of its variables. So when we get there, I know for compound interest, we only have 4 variables in the equation: present value, future value, interest rate, and n, the number of compounding periods. We can use math to rearrange that equation to perfectly solve for any of those variables. When we get to annuities, interest rate actually shows up twice in the one equation, and so you can't isolate interest rate all on its own, the way it works out. So that is one where the calculator has to iterate to find the answer. It's the sort of thing you would not want to have to try to solve multiple times on a test just to get closer and closer to the correct answer. You don't want to waste that time. Additionally, the calculator also takes care of some other handy things that we'll see, like the fact that Canadian mortgages are compounded semi-annually, but your payments are monthly or even more frequently. Well, the calculator knows how to tackle that if we give it the correct information. Because you have to, they don't stop charging you interest just, they when you make a payment, they don't keep charging you interest for the amount you've already paid. So it has to be taken into account properly, which is something you can do with formulas, but it's easier letting the calculator handle it. Even though I'll discuss how it does work for interest's sake. But in particular, on test 4, we are going to talk about the fact that when you're making payments on a mortgage and such, technically you are rounding off to the nearest penny, and so your last mortgage payment actually doesn't end up being exactly the same as the rest of the mortgage payments. And to calculate those sorts of things, you'll have to actually go through all the mortgage payments, 300 payments potentially. The calculator can do that in a few seconds. You do not want to have to do that manually yourself. So I hope I've convinced you. Like I say, it's math. I will take your answers as you present them. If you can get the right answers, great. But it's in your best interest to start to get used to the calculator even now, certainly by the start of Unit 3, just so that you're comfortable with how these functions work. And the slight quirks that do come up with the calculator. The calculator isn't intelligent. You have to realize how it's working and account for this. How it's just trying to balance an equation in its system, and that's what it's doing. Let's take a look at how what the function keys, the 5 keys, N, I/Y, PV, PMT, and FV, what they do, how, and what else we need to do in this in the calculator. So, first let's just discuss how the function keys compare. For interest's sake, and we'll get to this, when you're entering a number for any of these keys, so you can compute the value, compute with the top left corner button there, you can hit compute and then hit future value, FE, and you can compute any of those keys to solve for one of those values if you enter in the other values. And you don't have to, you can clear them or something, but I usually just make sure I'm always rekeying. I'm just keying in all the other values each time for each question. And some questions you'll have, you won't have to rekey everything every time. If you have several investments all at the same interest rate, then you can just put the interest rate in once. But, right, I was going to say, when you want to enter a number, you actually type the number first, 1000, and then you hit, PV, and that stores it in PV. Kind of like your memory keys from before. But you just type the number, then hit the gray key, and that stores it in there. Let's talk about the differences and what we're used to. So I said using the calculator for Unit 2, in this course, which is just compound interest. We are not getting into mortgages yet, or annuities. So, I'll reiterate it here, but PMT is going to be 0, the payment key there is going to be 0 for the entire unit. Never going to change that, or just make sure it's always zeroed. And PY equals CY. We'll talk about these, and I know I haven't shown you where PY and CY are yet. They're buried in the second function of the IY key, because they're talking about interest rates and payments and compounding and such. So, first one, N. N, capital N is equal to small n. That's easy. N is N. What was N? For our purposes, for this unit, N is the number of compounding periods in the investment. So, whether it's half of a year, or 7 years, or 20 years, we're curious how many times would the money compound over the length of that investment. We'll talk about what happened when we get to annuities. We're actually going to talk about N becoming the number of payments involved when we have regular payments. But for now, just consider N is what we've been using for N right now, the number of compounding periods in your investment. IY is J. It's the nominal interest rate, the annual interest rate. So the calculator finds the periodic rate, little I, for you. So that's kind of handy. Like I say, IY, you're going to put in the bank quoted annual rate. So, Yeah, actual annual rate. So, like I say, my mortgage rate is 3.5%. Great, I'll put 3.5. Yeah. Sorry, and that nominal annual interest rate as a percent. So, yeah, just to clarify, sorry, should add that. So, it's in the percent form already. So, like I say, 3.5% is written as 3.5. And that's it. 0.2% is 0.2. You know, so yes, don't turn it into the decimal form. Don't turn it into the periodic rate. So it saves you a step, which is nice. PV is PV, the principal or the present value. FV is the maturity or future value. Okay. PMT, so let's do PMT, like I say, is going to be 0 for now. For this whole unit, PMT is just 0. It will show up. I might not mention it all the time, but definitely on some of the worksheets, you're going to have, I actually put boxes so you can just fill in all these numbers. And for me, that will be showing most of the rough work you need to show. Is tell me what numbers you're doing in these boxes and then show me what you computed. That's great. That's what I need to know. That will be showing work. Unless there's a multi-step problem, then there might be like an extra step I'd like to see. But yes, payment is 0 for now. And like I say, and I know the word payment is ambiguous because we talk about payments on loans and everything. Well, this payment key is for mortgages and annuities. It is for regularly scheduled payments for mortgages and annuities. So if we have a short question with like, oh, you know what, you're settling this loan with 3 payments on some, at certain times. Okay, that is not what we consider a payment here. A payment is, like I say, oh, I've got a 25-year mortgage and I'm making monthly payments to pay it off, and then each payment is going to be exactly $1,200. That is a regular payment. So we will use it later for that, but for this whole unit it's 0. So a couple other things. So I'll get to PY and CY in a moment, but PV and FV, there's a quirk. This is the first quirk. Okay, when you're using the calculator, like I say, the calculator is just trying to balance an equation. So money in has to be balanced with money out. So if you buy an investment, then at the end, the investment pays you back, plus interest. So for purposes of the calculator, for this unit, payment is 0, and so PV and FV are just always going to be the opposite signs in the calculator. And it doesn't matter which way you do it. I mentioned here, if PV is negative, then FV is positive. For now. Most of the time, if you're just solving for PV or FV, you can put the other number in as whatever you want, and when you compute, you can just put it in as positive if you want, and when you compute the other one, it'll come out negative. It doesn't mean the answer is actually a negative number. It's purely the way the calculator has to figure out what's going on. Why is that? Probably because, obviously we don't need to do it when we do this with an equation, but the calculator is solving a more complex equation that takes into account mortgages. And for now, we're just saying, well, forget the mortgage, just it's 0 payment, there are no ongoing payments, so don't worry about it. And so we zero that out. But later, when we have payments also happening, well, now we have which of these 3 are positive and which of these 3 are negative, when all 3 have numbers involved, that tells the calculator, okay, am I making payments here, or am I paying out money? Am I borrowing money? Am I lending money? What's going on here? And so you'll have that sort of situation where, now, Okay, our convention. I'm going to stick to a convention. It's going to feel a little backwards at first. Feel free to do the opposite. Like I say, for this unit, it won't matter. As long as one's positive, one's negative, you're fine. And that will only become an issue, really, if you're solving for something like interest rate or for solving for the time, for n. Then when you put in PV and FV, you just have to make sure you put one in as positive and one in as negative. But our convention is going to be regarding cash flows. If you receive money, we call that positive. If you spend money, we call that negative. So, if I'm buying an investment, I'm taking money out of my pocket and buying the investment. So I put $1,000 in the bank, or I buy an investment for $1,000. I call that a negative $1,000 for PV. And then when the investment matures and has interest, I get paid back, $1,100 as my future value, and that would come back as positive. So I now have the money in my hands again, ready to spend on something else. So it may feel a little backwards. The other case is getting a loan. So when you get a loan for PV, what do you call that? We are calling it positive. Because I received the money. I know I'm going into debt, but I'm calling that positive. I received a $100,000 loan towards buying a house. And then I'm going to pay it back. And that's why you see, this is one of those cases where maybe I would pay it back for some number of years with a bunch of payments. So those would be negative, 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 negative as I pay that back. And maybe I would suddenly, at some point 5 years down the line, maybe I would suddenly have some inheritance and I'd want to pay back the rest of the loan. So again, future value, also negative to pay off the rest of it. So you can see where that's where, money to me, positive PV, negative payments and a negative final lump sum payment to pay it back. So this is why you can see why you kind of need to be able to manage those positives and negatives later on. But for now, don't worry too much. I will talk about that again when we get to it next unit. So as long as they're opposite signs, I don't care which way you do it. And the neat thing about all these investments is the math is exactly the same whether you are investing or whether you are taking out a loan. The math is going to be exactly equal. You just might, for our purposes, you might just flip which sign you use. If I'm investing $1,000, I'll call that a PV negative. If I'm taking out a loan for $1,000, I'll call PV positive. But the person on the other end is just doing the opposite as me. I invest they give me the loan, so they're investing $1,000 in me. So they'll call theirs negative, I'll call mine positive. So we're just trying to track which way the money's flowing. Like I say, on tests, I would rather see the answer just written as a positive number. You can write on your rough work to show, yes, I put this in as negative, I put that in as positive. It is nice to track that. Like I say, it'll matter more in Unit 3. It doesn't really matter too much now. I think if you do it wrong now, you potentially just get an error message anyways on the calculator, which is helpful, but you don't always. Sometimes you get an answer that doesn't actually make sense. So that's when it's a concern. Like n should never be a negative number itself. That's one of those things. N it should never be negative. If you get a negative value for n, maybe you've entered the wrong signs on those. N should never be negative. I know n should never be negative. So I know we used a negative exponent in our formula. Sorry, there's a lot of preamble. It'll make sense when we get on into all this. And definitely, you can review this calculator help sheet that I'll also have posted for you, which we'll go through this too and walk through one example, which I'll do with you in a moment here. But yes, n should never be a negative number. the calculator will understand, we'll tell it some positive amount of time for the investment or number of compounding periods. PV and FV, depending what we're computing, it will understand which way it's going in the equations. So, like in our previous calculations with the formulas, n was a positive number. It's just if we were calculating PV, we put a negative sign in front of the exponent. So, okay, so yes, pardon, trying to give a sense of what's going on with all this. Like I say, for all 5 of these, you type a number, then you hit the key. Type a number, hit the key, and that's how you put those values in. And we'll work through it. If you don't have your calculator with you handy, grab it and work with me in a minute when we do the example. PY and CY. Okay, so this is the last thing. You get to these by hitting the yellowish secondary function button, second function, and then you hit IY. That's where and then you can hit the up and down arrows, PY, CY, PY, CY. For our purposes, they are both, you can look on the sheet, my explanation too. They will be set equal to each other for this unit, because right now we don't have payments. So, but we want, the way the calculator figures out the math, we're just going to set them both equal to the CY stands for the number of compounding periods per year. So that is your annual, semi-annual, quarterly, monthly, daily, possibly. So that's your, like I say here, this number is going to, PY and CY for this unit is always going to be either 1, 2, 4, 12, or maybe 365 if you have daily compounded interest. But mainly those first 4. So, in particular, 1, 2, 4, and 12. Right? Annually compounded interest, semi-annual, quarterly, monthly. PY, like I say, stands actually for payments per year, and that is like related to your mortgage payments. Oh, if I'm making monthly payments, then that's 12. That is, when we get to that, yes, you could make payments twice a month, then it'd be 24. You could make payments weekly, then it'd be 52. So for now though, we're going to just set them equal, and in fact, when you set PY, it automatically sets CY to be equal. So it assumes they're equal to start. That's the simpler form of the math, in fact, when your payments line up with the compounding schedule. And like I say, we'll discuss in Unit 3 what happens when they're not equal. But we just want them equal now, and we'll want them equal to the regular compounding frequency. So remember, it doesn't matter if your investment is for less than a year, you still need this, if you are investing for only 6 months, but your interest compounds quarterly, you still need to tell it the interest is compounding quarterly. Even though, if you're only for 6 months, that means N is going to end up being 2 quarters of a year, 2 compounding periods. Yes, right, and yes, N, as with before, it's going to be M times number of years. And CY is going to be equal to M. And like I say, that's, we have annual, semi-annual, quarterly, monthly, and possibly daily compounding. So yeah, and like I say, you read that from the interest rate. Okay, thank you for listening to all this. Let's try a quick example of it. You know what, I think I will put it as the next short video, and we'll walk through an easy example, and then we'll start applying this to all the math we've been doing. And like I say, from this point on, I will use these values as how to explain what's going on, in the questions. And the worksheets show you rows of boxes. That gives you also a hint of at least the minimum number of calculations you may need to do on some of these multi-step questions. But yeah, sorry, I'm just gonna write into, you get to this guy by hitting this, so you hit the secondary key, and IY button. And that's how you get into these. And and when you're in there, we'll walk through this with an actual example, so we'll get the practice. But yes, second key, IY, and you put in your number, say quarterly, and you hit enter. And then you can see if you hit the down arrow, both PY and CY should be quarterly, and then you can hit second and quit or compute to exit out of that. Second IY, and you'll want to hit enter once you type a number to enter the number in. Okay, let's work through an example, and I think it'll make some sense. I'll come back in a second.